Okay, what we're learning about today is going to be chapter 1.6, absolute value equations. Now, when we are talking about absolute value is the distance a number is away from 0 on the number line. And when you are measuring distance, distance must always be positive. This is always a positive value. How do we denote absolute value? We denote absolute value by 2 bars. So an example, the absolute value of 8. How many units away from 0 on the number line is the number 8? Well, if you said 8, you would be correct. Well, what about negative 8? It is also 8, which means for every length of 8 units, there are 2 unique different numbers that have the same 8 values or 8 units away from 0 on the number line. Positive 8 and negative 8 are both 8 units away from 0. So how do we calculate absolute value? Well, we pretend that they're just like parentheses. So 8 take away 2 is going to be 6, and negative 14 plus 9 is going to be negative 5. The absolute value of 6 is 6 units. The absolute value of negative 5 is 5 units, to give me 6 minus 5, which is 1. Okay. Now, how do we solve absolute value equations? Absolute value equations, when calculating absolute value, you must always have 2 cases. Okay? We have the positive case, and then we have the negative case. Always. Extraneous solutions are solutions that algebraically come out correctly, but whenever you plug and chug, checking your answer, the solution is false. Meaning you will get something like 5 is equal to negative 3. That is a false statement, so therefore that's what we call an extraneous solution. Now, here are the steps to solving absolute values. Every time I say the word absolute value, your brain needs to understand that you have to first isolate the absolute value. Then we are going to see if it is possible. Then we're automatically going to do case 1 and case 2. We're going to solve, and then we're going to plug and chug to check our answers. So isolate, see if it's possible, case 1 and case 2, solve it, and plug and chug to check. So here we go. I give you, what is the solution of the absolute value of 2x minus 1 is equal to 5? Well, the very first thing we're going to do is we are going to isolate the absolute value. Isolate the absolute value is we're going to make sure that nothing else is on the same side as the absolute value of 2x minus 1. And the answer to that is it is already isolated. So I've already isolated this absolute value, which means step 2 is check to see if it's possible. Now, whenever I say see if it's possible, what that means is we're going to say the absolute value, I said previously, is always positive. And that is going to equal a positive outcome. Can a positive number equal a positive number? The answer to that is yes, it can. So that means I know this is a possible problem, meaning I know it's going to have a solution. It will not be a no solution answer. Which means now I need to immediately go into case 1 and case 2. Case 1 is I'm going to drop the bars and set it equal to 5. Case 2 is I'm going to distribute a negative into the parentheses, and that'll be my case 2. So what I'm going to do is I'm going to solve case 1. So 2x is equal to, I'm going to add 1 to both sides to give me 6. Divide by 2, and I get x is equal to 3. Okay? I'm going to come over here and do the same thing with case 2. Negative 2x plus 1 is equal to 5. Subtract the 1. I get negative 2x is equal to 4. So x is equal to negative 2. Now, I have determined that I have 2 solutions. Now, if you look at my steps that I just told you, we went ahead and we isolated. Then we checked to see if it was possible. Then we did case 1 and case 2, and then we solved. Well, the last step is to plug and chug and to check your answers. So we're going to do that. So basically what I have is I'm going to have the absolute value of 2 times 3 minus 1, and that has to equal 5. Well, 2 times 3 is 6. Minus 1 is going to be 5. The absolute value of 5 is 5. So 5 is equal to 5, and that works. Same thing. Then I go right back to the original. And now I'm going to plug in -2. So this is 2 times -2 minus 1. So that's going to be -4 minus 1. Cannot read that for some reason. My board did not like that. So I'll fix that. Sorry about that. That's going to equal 5. So this is -5 inside the absolute value bars to give me a 5 is equal to 5. And that is true. So therefore, -2 is an answer. So the two answers that I have for this problem is going to be 3 and -2. You must check each one of these to see if you're going to get an extraneous solution. Every time. So let's go ahead and do it again. Same exact process. Don't know why I have that one there again, so I'm going to delete this. So next, here we go. Step 1, I need to isolate. Meaning, are there any other terms on the same side as the absolute value bar? The answer to that is no, there's not. So next, I'm going to go ahead and I'm going to check to see if it's possible. This outcome is a positive and it's going to be equal to a negative. When does a positive number ever equal a negative number? The answer to that is negative. Never. It never equals that. So therefore, this is a false statement, which means there is no solution to this problem. And you're done. Now, many of you probably would have done this problem and taken the long, hard route. And the long, hard route would have been to go ahead and to say, okay, let's do case 1 and case 2. Well, case 1 is 3x plus 2 is equal to -3. So I'm going to subtract the 2. So I get 3x is equal to -5. So x is equal to -5 thirds. Over here is negative parenthesis 3x plus 2 is equal to -3. So -3x minus 2 is equal to -3. Add the 2. And 3x is equal to -1. So x is equal to 1/3. Now, none of this work is necessary. I repeat, none of this work is necessary. And the reason why none of this work is necessary because had you did this at the beginning of the problem, you would have seen that a positive never equals a negative and there's no solution. But let's say you didn't do this, and this is the work that you showed. Now from here, you actually have to plug and chug. So this is going to be 3 times -5 thirds plus 2. So the 3's cancel out, and I'm left with -5 plus 2, which gives me a -3. Come on. And the absolute value of -3 is 3, and 3 never equals -3, so therefore that is not an answer. This is false. Same exact thing over here. 3 times 1/3 plus 2 is equal to -3, so that's 1 plus 3 is equal to -3, so that's the absolute value of 4 is equal to -3, and 4 does not equal -3, so again, this is not going to work. Okay? Now, so all of that to show that no solution was the answer. So what do we always want to do? We always want to check to see if it's possible because it's just helpful. All right, so our next problem. I have 3 absolute value of x plus 2 minus 1 is equal to 8. So step 1, I want to isolate this absolute value. So that means I need to get rid of the 3 on the outside and the 1 on the inside there. So I'm going to go ahead and I'm going to add 1 to both sides. So I have 3 absolute value of x plus 2 is equal to 9. Still need to isolate. Now I only want to do this if the number that I'm dividing by, which is a 3, is divisible by this number 9. If it's not divisible, then don't divide. Just continue to work with it, okay? But in this case, it is divisible by 3. So I have the absolute value of x plus 2 is equal to 3. So now I've isolated. So now I want to check to see if it's possible. The absolute value always has a positive outcome, and that is going to equal to a positive number. Is that possible? Sure it is. Which means now I'm going to go ahead and I'm going to do case 1 and case 2. So case 1 is going to be x plus 2 is equal to 3. Case 2 is going to be negative, putting in front of that x plus 2 is equal to 3. Subtract the 2, and I get x is equal to 1. Distribute. Add the 2. Divide by -1. and you can't read that number because my board doesn't like it. And you're going to get x equals 1 and negative 5. Now, let's be honest. Are we done? We absolutely are not done because now we have to go back to the very beginning of this, and we have to plug and chug and check that. So I'm going to add a new page so that you can see my plug and chug a little bit better. Okay? So I'm going to check these. So I have 3 absolute value. Absolute value, x is going to be 1 plus 2 minus 1, and that's supposed to equal 8. So this is going to be 3. The absolute value of 3 is 3. So 9 minus 1, and that's 8 equals 8. So yes, that does work. So this has been checked, and it is accurate. So now we're going to come on and do the next one. So that's 3, absolute value of negative 5 plus 2 minus 1. So that's 3. Negative 5 plus 2 is negative 3. So the absolute value of 3 is negative 3 is positive 3. 3 times 3 is 9. Minus 1 is 8. 8 is equal to 8. So that equals as well. So both of those equal. Now, here's what I'm going to tell you. When you have a variable only on one side of the equation, 90% of the time, both answers will work. When will both answers not work? Well, both answers will not work whenever we are in a situation like this one right here. When I have a variable on the left and of the right side of the equation. This is when extraneous solutions come into play, which means you will always have one of them about 75% of the time that will not work. Okay? So, step 1, we're going to isolate. This is already isolated. It's already by itself. So we are going to check to see if it's possible. Well, here's the problem. I don't know what x is, so I really can't check to see if it's possible. So I immediately go into case 1 and case 2. So case 1 is 3x plus 2 is equal to 4x plus 5. And then case 2 is the negative in front of that, so 3x plus 2 is equal to 4x plus 5. So I'm going to go ahead and solve case 1. So I'm going to subtract the 3x. I have 2 is equal to x plus 5. Subtract the 5. Negative 3 is equal to x. Come over here to case 2. Negative 3x minus 2 is equal to 4x plus 5. I'm going to add the 3x over. So negative 2 is equal to 7x plus 5. Subtract the 5. Negative 7 is equal to 7x. Divide by 7. And negative 1 is equal to x. Now, remember, I said 75% of the time, one of these is not going to work. So I'm going to check my answers over here for you to see this. So if I come over here and I plug in my green answer, okay? So this is going to be 3 times negative 3 plus 2 is equal to 4 times negative 3 plus 5. So this is negative 9 plus 2. This is negative 12 plus 5. Negative 9 plus 2 is going to be negative 7. That's going to equal negative 7 on the right. This is 7 is equal to negative 7. That is a false statement, which means this is not a workable answer. So now I'm going to come over here and I'm going to do the other one. Chances are negative 1 is my answer. So this is going to be 3 times negative 1. Sorry, I forgot this. Plus 2 is equal to 4 times negative 1 plus 5. So this is negative 3 plus 2 is equal to negative 4 plus 5. So this is negative 1 is equal to 1. The absolute value of negative 1 is 1, so 1 is equal to 1. And that is a true statement. So therefore, we know that we are right. And the only answer that I have is x is equal to negative 1. This is my answer. Negative 3 is an extraneous solution. Next, let's keep going. Step 1, isolate. So here is going to be my absolute value, so I need to isolate this. The way I'm going to do that is I'm going to add 3. So So I have the absolute value of 2x minus 4 is equal to a negative 7. So it's all isolated, so now I need to check to see if it is possible. The absolute value is always a positive outcome, and that's going to equal a negative outcome. When will that be true? That is never true, so therefore that is a false statement, so therefore there is no solution. Okay? Tonight's homework, you have for me Chapter 1-6, Worksheet 1, Absolute Value Equations. Be sure you have case 1 and case 2 for all problems, and you've checked your solutions. That is tonight's